Okay, great. So thanks for this opportunity. Thanks for turning out in large numbers for this. So I'm gonna be talking about AI, right, in particular, and cloud and data. The relevance to this track is obvious because AI is basically the stuff that you do on top of data and cloud and build a lot of exciting stuff. So unless you guys have been living in a cave or under a rock over the last couple of years, you probably already know, right, that this is a very, very exciting time for AI, right? And as I said, data and cloud are really the enablers, right, for this revolution. Availability of, easy compute, lot of rich data sets, both public and private, is really what's causing, this whole field to grow. Right. So basically, the theme in my discussion is really going to be that, how do we actually create real value, right, out of AI? And developers are really very central, right, to this whole notion that, AI is going to do big, impactful things for the world, right? And to sort of lead into that topic, I think it's important to first talk about there are these two conflicting views, right, that are prevalent, I would say, right, somewhat conflicting, I would say, right. So one is kind of this popular culture view of AI, right, which essentially is that machines will become sentient, take over the world, generalized artificial intelligence, right. And this is where people are more concerned about that how AI is going to replace jobs because of automation and so forth. A more alternative view, which I'm sure you can guess that that's the view that we subscribe to, is basically where AI augments intelligence, right? It basically helps doctors diagnose difficult diseases like cancer better. It helps in doing things like mass personalized education, right, or solving other big challenges of our time. And that's really the view of AI that I'm going to lead with, and sort of appeal to you guys as developers in terms of what the opportunity is. So if you look at this picture, right, I mean, on the left corner is basically this tons of data, right, that we now have access to. So digitization of the world has led to this side effect of creating huge amounts of data, both structured and unstructured. And as you guys are familiar, traditional computing systems are not really designed very well to work with unstructured data. So let's take cancer as an example, right? All the human known knowledge about cancer is actually captured in about 15 million pages of text, right? This is not an Excel sheet, this is not a database, right? It's basically text, right? So the ability of systems, right, to be able to understand this data and reason based on that, right, is basically the paradigm shift, right, that is happening, right? So you have all of this data from different domains, education, law, finance, travel, what have you, right? That's on the left, right? Then, the second element is basically your weapon, which is on the right, right? Availability of APIs on cloud for you to, kind of really use AI not as something which is very niche. So for example, nowadays, if you want to write a, convolutional neural network or want to do, some, computer vision work, you don't really have to start from scratch. And this is a big deal, right? Because this unlocks innovation, very fast. You guys are not you don't have to go through sort of this long trudging path, right, to get to, what you can, start to do with all of this data, right? So the availability of AI APIs like Watson, right, on the cloud is basically the second lever, right, which is enabling this revolution. And then on top is basically all the big hairy problems that we believe, right, that we can solve with AI, right? And this spans healthcare, education, law, financial inclusion. This is, so one of the perspectives of AI is that, it's great to, you get a high when you can, figure out a picture of a dog, in an image, and figure out that two people are hugging and stuff like that, right? Yeah, that's also, cool AI, interesting stuff to do. But, the real opportunity, which is kind of the theme of this talk, is basically on the top, right? Solving some of the biggest challenges of our time, right? We actually think, and as the cancer example that I gave you, your ability to basically work with those 15 million pages of unstructured text is something that has unlocked your ability to help doctors crack cancer, right, as an example. So we're going to focus on that narrative, right? And, you guys are really, the knights in shining armor or gladiators, whatever you want to call it, who we are depending upon to use this power at your disposal, right, and crack some of these big problems, right? So let's make, so just for context, right, for the rest of the talk, right, cognitive computing systems are different from traditional computing systems. They can actually understand your world, right? It's not just ingesting that piece of text, but actually being able to understand that it's talking about, let us say, a part of the human anatomy, or a gene or a protein or a particular type of cancerous tumor and things like that, right? Or about, what does a shareholding in a company mean, right? These are kind of concepts that are out there, right, in the world, and these systems can understand those concepts. Secondly, they can learn at scale. These systems get better over time, right? And that's sort of inherent to AI or deep learning or machine learning, right? Whichever flavor of AI, whichever flavor of cognitive you guys are actually working with, that these systems get better and learn at scale. Then, of course, is the end game. You want these systems to be able to reason with purpose, right? Suggest, make a recommendation on a treatment option, for example, right? And finally, interact naturally with humans. So, this is kind of if you see like a tip of the iceberg analogy, right? Most people actually tend to see AI as sort of this top piece that, okay, I can do some natural language conversation, build a bot, stuff like that. That's cool, but if you're actually building these systems to solve complex problems, you will actually notice that 80% of the effort is actually in the layers below. Yeah. And that's where we need your expertise, right? The top part is pretty commoditized, very easy to do, but it's also important. So having said that, right, I mean, let's make it concrete, right? What does it mean to take on a grand challenge with AI, right? So we will take cancer as an example, right? And it's important for many interesting reasons. This was one of the first areas in which we started to commercialize our AI. And also, Manipal Hospitals, which is our sort of reference client for this, was actually only the second or the third, I believe, client all over the world who actually were progressive enough to adopt this, right, in their oncology departments. So it's very special to us, right, from many reasons. Why did we pick healthcare, right? It's a big, hairy problem, and AI has some, unique ability it gives us, right, to actually crack this. So just for reference, right, so in India, and these are India specific, I'm not going to average this out by giving sort of global statistics, right? So, close to 680,000 lives lost to cancer each year in India. About 1 million new cases diagnosed every year, right? And this will become 5x by 2020. Now, the issue is we cannot create expertise fast enough. So 1:1600 is the ratio of oncologists to cancer patients in India, right? And as the disease grows exponentially, you just can't create enough oncologists, right, to crack this. So this is a classic example of scaling expertise, right? Which is, and this is very specific to India, right? Because, or rather I would say amplified, right, in India. Because if you look at similar things, right, education, student to teacher ratios in classes, right? How do you do mass personalization of skilling, right? And how do you do personalized education for a kid who may be strong in a particular area, not so strong in another? How do you, one teacher just cannot, do this personalized, kind of planning for each of the kids. So you will see that in India, we have a lot of these kind of issues which are, characterized by huge scale, millions and billions, and then at the same time shrinking or not growing fast enough expertise. So AI tends to be an exact fit, right, in these kind of cases, because AI is essentially codifying expertise, right, and it's basically trying to make it available at scale. So, that reflects, of course, in this scenario as well. And, the other interesting thing is that how fast is new knowledge getting created. So, on an average, close to about 40,000 plus new research papers, right, get published every year in this space, right? How are you gonna, so even if an oncologist didn't sleep, didn't eat, all the time he or she was reading these papers, and then they had 100% recall when they were actually addressing a patient's case, still, you will not be able to keep up with the rate at which this knowledge is getting created. And this is sort of a recurring theme you will see across industries, right? And this is where AI is actually foundational to be able to crack these kind of problems, right? So for example, like I said, 15 million pages of text, we ingest it in Watson, we try to understand it, and then, in Manipal, they recently presented the results of their first year of usage, right, of Watson, and they actually found 90% concordance between, the tumor board at Manipal hospitals and, Watson's recommendations, right? So this is a pretty big deal, right? This is a pretty big deal. And, it takes effort, it takes depth, right? So we are basically, our mission is actually to enable you guys to become superheroes in these respective fields by being able to do similar stuff, right? So this is just a picture of kind of, how based on a patient's personalized, history, the AI actually suggests evidence-weighted treatment options. So I'm going to skip that and just show, sorry, did I lose the, okay. So, and you will see, again, cancer is a pretty deep subject, requires a lot of time to sort of specialize the AI to it. But of course, there are other, real applications with a lot of value. For example, in banking, telecom, commerce, you will actually see mass personalization, right, at scale is actually a key element to really enabling digital, right? You can't scale, back-end sort of human power in front of a behind a digital interface, right, without mass personalization. You have, things like retail causal analytics, digital lending, corporate lending risk, right, procurement intelligence, any kind of knowledge work, call center or BPO, organizational knowledge management. There are oil and gas companies which are actually using AI to, codify 30 years of their project experience and reuse them as best practices. So, whichever is your favorite industry, whichever is your, as they say, pick your poison, right? Whichever area sort of excites you and, has some of these characteristics in terms of large availability of data and this kind of reasoning requirements, you will actually find a great fit. So, depending upon where you are engaged, this is actually something that's relevant to you. So I'm not sure why this is not working, but happy to do this. So, as developers, right, you need to understand the next level of detail, right? So, okay, some of this stuff is cool, but then how do you, start to sort of build some of this stuff? So APIs are one element of this, right? But the second more important element is the right design patterns, right? So in most AI problems, what tends to happen is that, yes, there are these, micro APIs that will do pieces of the puzzle. But as developers, you guys really need what are the right design patterns, right? Or a developer journey, if you will, right? That you need to go through. So for example, to make the AI understand a particular domain, right? So let us say you've just seen an example in case of oncology. What if I wanted to really make the AI understand, let us say, the financial services domain or the law domain, right? I want him to understand sort of, legal terminology and so forth, right? So this actually follows these so-called, design patterns, right? So, and I'm just illustrating this, because from your perspective as developers, you guys can get sort of a mental sense of what, what's available to you, right, in terms of building this stuff. So, what tends to happen is that, generally, a lot of these APIs, right, for example, natural language understanding, right, could be an API. It will generally not be trained on individual domains, right? So for example, if you take natural language understanding API from Watson, it is trained on Wikipedia. So it basically understands, concepts like, places, companies, and, people, stuff like that, right? But you need to make it understand, for example, what a gene means, or what a protein means, or what, like I said, company shareholding means. Or if you're using it for oil and gas, what does a oil rig mean, right? And so forth. So this terminology is domain specific, right? So you need to give the AI domain specific understanding. So so in the pipeline of actually making the AI understand that domain, you basically have to then give it what are called, ontologies, right? Or a type system, which is specific to that domain. So the API will basically tell you that, how to create that type system, right? And you will use it together with some training data. So for example, when we train Watson on, let's say, oncology, we actually give it, examples or against that type system, which basically tell it that, okay, how to interpret entities and relationships, right? So for example, a particular gene, right, is suppressed by a particular protein or a chemical, right? This is two entities, and there's a relationship between them. So fundamentally, the API allows you to actually do those kind of annotations and sort of bring that together with a type system. And then what you get is an AI which now starts to understand that particular domain. And this is an iterative process, right? You can keep refining it, it gets better over time. Then essentially, the hygiene sort of steps are that generally you will have some known information, right, already about your domain, right, about your world. So for example, you may already know about certain kind of, gene and protein interactions, right, in the context of cancer. So you will bootstrap that information by actually, priming this with a, these entities and relationships, they basically sit in a knowledge graph. So much like how our brain maintains information, right, or knowledge, it basically does it by recognizing entities and relationships between them. So you bootstrap part of what you already know, and then as new information keeps coming in, so let us say, in a financial services domain, let us say you were assessing risk, right, for a particular company, that, should I extend a corporate loan to a company or not, right? So there are two elements. One is what you already know about the company and companies, and that is basically the bootstrapping knowledge. You have trained the AI to understand that, for example, what constitutes risk, what does it mean to kind of do a share transfer, or what does it, how directors of the company are sort of linked to each other. These kind of relationships you train the AI on, and then as dynamic information keeps coming in, for example, news, right? So let us say there is financial news about mergers and acquisitions and so forth that's coming in. You feed that to the domain annotator, and it gives you this dynamic piece, right, of the graph. You marry them, get sort of the end-to-end knowledge graph for your domain, and then any practitioner, whether it's a doctor or whether it is a a loan assessor or a risk underwriter, right? They will then be querying this knowledge graph, right? In sort of a graph query way, right? Like using Gremlin or whatever other favorite language you may have. So the point is that it's not enough to just have AI APIs available to you or data available to you. You have to marry this with these journeys or these design patterns which represent how to actually make the AI relevant to that particular domain. So a similar example of a pattern is what is called a virtual agent, right? So people tend to call them chatbots, but actually if you see in the real world, right, most of these chatbots are essentially messaging sort of client-server type of applications. They're pretty dumb, right? I mean, they don't understand the domain, and they generally do not have the ability to draw upon what the organization knows and make, let us say, very personalized recommendations. That requires a whole bunch of work at the back end. So as some of you know who may be familiar with machine learning and so forth, a lot of these things like personalized recommendations, etc., are basically machine learning activities. So again, you have to often marry, right, pieces of the AI, right? So the natural language part of this AI is basically at the front end, whereas at the back, you are using a whole lot of what an organization, let's say, knows about its customers, right? It could be sitting in transaction databases, it could be sitting in CRM and so forth, and use that as a separate piece of AI, right, which is more towards, not so much towards natural language, but more towards machine learning. Marry them together in a pattern to actually make a really intelligent contextual bot, right? So what we are basically beginning to do, right, as an effort to make it sort of accessible for developers to sort of, create these kind of patterns is that, we obviously in our world have access or visibility to a lot of these interesting use cases, right, that we see, right, with our clients. Basis those, we are actually going to make these developer journeys or these, design patterns, if you will, available as actual code, right, on GitHub, right, on IBM's developer works site. And then these become, very interesting starting points for you guys. So instead of trying to figure out from the raw APIs, so for example, this pattern, this uses at least 3 APIs, if not more, from the Watson suite to actually really get to its end state. The previous one that I showed you, right, basically the making the AI understand a particular domain, that also uses at least 3 to 4 APIs, right, in a particular sequence. But what is not evident is just by looking at the API, you do not get that what is your information processing pipeline, right? So these design patterns are equally important to developers, right, and not just these APIs. So we are going to put our weight behind this and make a lot of these design patterns available to you as real code, so that you don't have to relearn, right, some of these elements, and you can start from yet another higher level of abstraction, so to say. So that's going to be, and then when you bring this together, you will actually recognize that, see, most of the times when you're going to do something which is end-to-end, but let's just make it up. I mean, let's say you are creating an AI for law, right? So it has all of these elements, right? It basically has, what's the data that you will work with, how will you make it understand the legal domain. And in some cases, you might be able to use APIs, and in other cases, you might actually have to go raw. Raw meaning native AI, right? Where you are doing your own neural networks or your own machine learning models. So it's very important to give developers not just these APIs, right? But when you need to go deep and native, you should have the ability to do that too. So this picture actually illustrates that, in these solutions, you generally think of an overall AI solution in 4 layers, right? One is your choice of the platform. Obviously, you don't want to do, all of this custom, buying your own GPUs and so forth, right? So cloud is pretty central, right, to AI development. On top of that is your content strategy. So as I was showing, right, it's a mix of structured and unstructured data depending upon your domain, right? So you basically nail that down. On top of that is basically the core AI. Now, this is a mix of, like I said, either your own native custom models or something that is already available in the API. So, for example, natural language understanding is not something you need to recreate, right? You should ideally use an API, right? Similarly, probably for vision. But if you're doing a custom model, which is a recommendation engine, let us say specific to a client or specific to a domain, you obviously need to be able to do that yourself. So for that catch-all, right, we also provide something called GIDS.Data platform, which basically is a data science, kind of toolkit. So you will see some examples here, right? This is basically a Jupyter notebook, which some of you guys may be familiar with. So those kind of tools that developers already use, right, for data science, those are also available, and you can build your custom AI. There's a traffic sign recognition and a lane detect. This is actually a self-driving car example, right, where we've actually shown on a Jupyter notebook, right, native AI development, also combined with some of the API-based conversation stuff on the top, right? So generally you have to think about this in these layers, and then we make available both a native platform for you to write your own AI, as well as use APIs where relevant, right? So that kind of completes the picture for a developer in terms of what all they might need, right, to actually build a significant AI solution. My time shows up here, so I'll just conclude with a couple of closing comments. So it's also important to realize that so AI APIs is one piece, right? But of course there are other things, right, that you may need. So we are seeing a lot of interesting patterns that actually marry AI with mobile applications, with analytics, with blockchain, right, and so forth. So, again, the Bluemix environment, which is, kind of our DevOps PaaS environment, that basically enables, a very rich set of these other APIs also, which you typically might need in addition to, the AI API. So essentially that allows you to do a holistic end-to-end development on cloud. And I'll just leave you guys with a couple of pictures. You guys are developers. Hopefully you get excited with the kind of cool stuff that we are doing, cool stuff that developers are doing, right, with this in, all over the world. So I'll just leave you with, kind of some of these. So this is actually a robotic concierge that's built on Watson, right? It's at the Hilton Hotel in the US. This is a company that's actually personalizing travel and hospitality, planning vacations, etc., using AI. This is a self-driving bus, which is actually also 3D printed, right, which is actually powered by Watson. This is, our work with BMW in the, cognitive car and IoT space. We actually done work with fashion designers. So this particular dress, right, is actually a cognitive dress. So it's IoT and cognitive. So, when the social sentiment on a particular hashtag related to this dress, when its sentiment trends, right, the dress actually changes color. So I mean, it's a bit crazy, but, it's interesting stuff. I hope, you guys find. Then, cognitive playtime. So there's a company that has actually built a cognitive dinosaur, which is powered by Watson. It can play with your child and sort of, help them learn, right, by talking to them. We are doing a lot of work on personalized education, right, with schools in the US and also with Sesame Street. So that's the mass personalized education work. Cognitive cooking, National, Culinary Institute in New York. They've worked with Watson to help, ingest all the cookbooks in, for different cuisines. And Watson can actually suggest dishes. In many of our Watson conferences, you can actually taste these dishes, right? There's a counter. Watson suggests something, and, you can basically try how it is. And I've tried many of them. It's pretty good. Creativity in music and in movies, right? I mean, this is a film whose trailer was created entirely by Watson, right? By actually picking out what were the high points or climactic points, right, in the movie. So it synthesized the trailer on its own. We've recently announced with H&R Block, this year, all the tax filing in the US through H&R Block is actually going to be done through Watson. So there will be a bot through which, people will, talk and give their information, and it will tell them what are the best deductions that are applicable to them. And finally, at the Masters tournament recently, it's a golf tournament that IBM has been associated with. We've done this very cool sensor fusion project in which there is something called a cognitive room. So, you can get actually a 3D immersive view of the entire golf course. You walk in, and using sensor fusion, we can detect who you are, right? We can talk to you, and, if you want to see that, okay, what's happening at the 18th hole, what is the leaderboard right now? You talk to the room, right? And it basically, projects on the wall, all the things that you might be concerned with. So in digital engagement, personalized engagement, this is a very, very cool idea, which is gaining a lot of traction. There is a video called Behind the Code, where our key lead software engineer talks about, how he built this. So I encourage you guys to go check it out, right? And maybe even try that. So, I think the message I want to leave you guys with is that, the AI, I mean, this is not a fad, right? This is actually something which is extremely foundational to, kind of the next wave of what we can do, right, as developers. This is going to help us crack some of the most difficult problems of our time, right, which were not possible before, right, without this computing paradigm. So you guys are at the center of this, right? And what we really expect and would want to encourage by putting these developer patterns, these APIs out there, is that you guys go on to crack, some of these big problems of our time using AI. Okay, so that's my talk. Thank you.